Saxon Algebra 2. Greetings, students, to the first lesson of the last week of the year. According to your sheet, we're doing 117 through 120, but as you know, I've just changed my mind on that, and I'm mixing it up a bit. So I'm drawing some new boxes. Well, they're not very even, but just pretend. We're going to do lesson 118, lesson 119, 120, and 121. We're not doing those. I'm still going to cross those off. I don't know what I'm going to do. Let's do this. We're not doing those. We're doing these, all right? So right now I'm going to do lesson 118. If you want to copy these numbers down and kind of redo your check sheet like I'm doing, or you can just cross off those. I don't care, whatever you prefer. And then here's another way to see it. These are the 4 lessons we're doing this week, and I'll explain this in just a minute. Lesson 118 is about logarithms. I know, you're still hyperventilating from our last conversation about logarithms, but again, I don't expect you to understand this perfectly. I just want you to know enough to be dangerous. And the next time that you see these, you'll be like, oh yeah, it's not that bad. That's what I hope you'll say. But in order to do this lesson successfully, we have to go and get some information out of lesson 122, which I don't understand why John does them this way. It makes no sense. But I'm going to give it to you in the logical order. Laws of logarithms. That sounds impressive, doesn't it? Okay, you guys know this chart. I'm going to change it a little bit. Okay. I'm going to divide this into 3 sections. I'm making the top one a little bit smaller and the third one a little bit fatter. In the first one, I'm writing rules for exponents, and I'm just going to shorten that to EXP. And then in the next column, I'm going to write laws of logs. All right. Now, these you've seen many times before. There's a product rule for exponents. It says that if you're going to be multiplying numbers that have a matching base with exponents, you can add the exponents together. Now, let me show you the law of logarithms that goes with, very similar to this. Whoops. It says that if you've got an expression that looks like this, you can separate those two out and add them. Or if you've got it arranged like this, you can multiply them together. Can you see how we're linking multiplication and addition? That's what makes these similar. I'm not going to get into a big philosophical discussion of how this relates to that. I don't want to confuse you. I just want you to see that, oh, addition and multiplication go together in these laws just like it does in these rules. Let's do the quotient. Remember in this one, we said that if we're dividing, we can subtract the exponents. Well, guess what? If we're dividing with our logs, we can subtract here as well. Oh, that's kind of cool, right? They fit together. This one matches the least, obviously, but it's a really cool law of logarithms, and it's one of the best ones to know. The power rule says, if you've got a base with an exponent and you're raising it even higher, then you can multiply those together. This one, the logarithm version of it, is really weird. I'm going to use an x. This says if you've got a logarithm and there's an exponent up here, you can jump it down and make it a coefficient out in front. And again, just like all the logs of logarithms, as well as these, you can use them in reverse order too, right? So if you've got a thing out here and you don't like it, you can jump it up as an exponent if you want. Huh, interesting. So what I want you to see is that even though I'm throwing these things at you and saying, look kids, laws of logarithms, isn't this fun? It's not something new that I've made up. All we're really doing is taking these rules for exponents and reshaping them for the logarithm format. Again, I don't want to get into a big conversation about how this really is exactly like this, but just trust me that underneath, it's the very same principles at work, okay? We're relying on the same essential truths in order to make both of these work. We're going to do some problems where we'll practice using these, and it's going to be fun. My last observation is, doesn't law of logarithms sound way more formal and official than just a rule for exponent? Laws, whoa, that's just like, that's intense. So I always feel like exponents got the bad deal on this because their name is just not as cool. Okay, this is presented in the book in lesson 122. However, you need this to do the problems in 188. So John kind of went out of order. Let's do a problem. Solve. Oh, I want to say one more thing about it, but I'll write this down first. I did not put a specific base on these, but the base always needs to match, okay? I could write little tiny b's in there. I don't want to do that. That's confusing. The bases have to match in order for this to work, just like the bases have to match here in order for these to work. So here, in this first example, John's showing us it's base 3. Don't let that freak you out, like, because you're like, base 3, I don't have that on my calculator, and what does that even mean, and I don't know how to do it. Don't worry about it. As long as they match, that's what's important for us. What we do when we look at this is we recognize, oh, look, we're adding these two logs. That means we can use this law of logarithms, right? Here's where we're adding, to multiply them together. So it's called the argument, this part of the expression. The number, or the argument, is the fancy name for it. This says that if you're adding two logs, you're allowed to multiply the arguments and write them as a single one. So we can rewrite this as log 3 x plus 7 times 2. I could have written the 2 first, but I just left it like that. Equals log 3 20. Now, here's something that feels weird. We're told that the exponent that you put on 3 to get this is the same as the exponent that you put on 3 to get that. Therefore, ready to have your mind blown? We are allowed to take this part off and solve it separately. Once we get it so it's log and log on each side, we can say that, I'm going to put the 2 first this time. 2 times x plus 7 equals 20. If the exponent that you put on 3 to get this equals the exponent you put on 3 to get this, then these two things must be equal to each other. That's weird and hard and kind of mind-blowing. For now, just trust me and take it off. Again, we can't do it at this stage because we have 2 pieces. We have to smush it into one piece, then we can take it off. And now we just solve it. 2x plus 14 equals 20. Swim some little fishies. X equals 3. Oh. Oh. Right? You can do that. That's not that bad. All right, I'm going to keep this handy, but I'm going to start another page. Example 118.2. Solve. I'm going to write it here so I'm not squished. Log 14. Okay, don't panic. It's going to be fine. X plus 3 minus log 14x minus 3 equals log 14.7. Okay, as soon as we see this, we go, oh, subtraction. That's on our page, isn't it? Look, there it is right there. When you're subtracting, you can take the arguments and make a fraction out of them. All right, let's do it. So there are the two arguments that we're subtracting. So it's going to be log 14. We still have to write that at this stage. X plus 3 over x minus 3 equals log 14 of 7. Remember, we don't care if that's a weird log, a weird base, because we're going to get rid of it in a hot minute anyway. Now we're saying, okay, the exponent you put on 14 to get this equals the exponent you put on 14 to get that. So that means this must be equal to that. So we can write it that way. And now we're just off to the algebra races. This is easy. We'll cross multiply, right? And we'll get 7 times x minus 3 equals x plus 3. I'm going to subtract the x that way, and I'm going to add the 21 that way. 2 steps at 1. Oh, my book just fell unclosed. 6x equals 24. Oh, I like that. X equals 4. Grace, stop licking your paws. I don't mind that she licks her paws, but she is a very slobbery lady, and she makes great big messy spots all over everything. But she smells really nice. I've been squirting her down with conditioner, mane and tail conditioner for horses to help keep her fur smooth, and it smells delightful. This is the right answer. Weird, right? But okay. Let's do one more, and then we'll be done. And you'll feel like logarithms are not going to kill you maybe after all. 118.3. You'll never guess which one. Which law of logarithm? The first example was this one. The second example is this one. Do you think? I do. Ready? Solve. 3 log b of x equals log b 64. We are not going to let that b freak us out. We've seen in these other two problems, we're just going to lift the arguments off anyway. So it's fine. But first we have to fix this because we can't lift the log off when that 3 is hanging out there. So now we're going to use the third law of logarithms. We're going to take this dude and we're going to jump him up and turn him into an exponent. That's wild, isn't it? It's going to jump up there. So I'm going to say log b x to the third equals log b 64. Now that we have nice clean log expressions on each side, now we can take the arguments off. And we can say x to the third equals 64. Oh, and that's pretty easy. We can say x equals 4. Yay. That was the answer of our last problem. We had 2, x equals 4. But they're both right. All right. So, again, John's kind of drunk because in order to do lesson 18, we have to have this chart, but he doesn't give us this chart in proper form until lesson 122. So I can't explain that, but I can say, there's the chart. Yay, use it, and good luck. Okay, goodbye.